Good morning, class. We are looking at Chapter 4, Applications of Derivatives. Here's 4.1, Maximum and Minimum Values. Maximum and Minimum Values. So we are going to look at maximum and minimum values, how derivatives affect the shape of a graph, optimization problems, antiderivatives. Antiderivatives is the reverse process of differentiation, also known as integration. And you have to be very good at differentiation to be able to do anti-differentiation. So a lot of formulas that are here, you should be comfortable with. Just like if you want to be good at division, you have to know multiplication first. So we have definition, basic differentiation, product rule, quotient rule, composite function, chain rule, power rule, extended power rule, exponential rule, logs, and then we added the concept of delta y versus dy. Delta y is the rise if you go from point P to point Q. The run is delta x. Rise along the curve, that means f of x plus delta x minus f of x. And dy, we know f prime is dy dx, dy is f prime of x dx. We can approximate delta y by dy, and therefore notice delta y, the rise along the curve, dy along the tangent line. They are not the same, but it can approximate that. The smaller the delta x, the better this approximation. Also, the concept of a linearization at this point, instead of coming up with this formula, just use the point slope, and that's the linearization, the tangent line. Meaning, at point A, whether you go with the function or L of x, they both give you the same answer. But nearby, they don't. But if it's very close, either one is fine. L of x will be the approximation for f of x at those values. Okay, so that's the idea behind linearization. Now, maximum 4.1 maximum and minimum values, definition, critical point, or short CP, is defined as a critical number or point of a function f is a number c such that f prime is 0 or f prime does not exist. And we want to find the critical numbers for the function f of x equals x cubed plus 3x squared minus 24x. The process is as follows. First, find f prime of x. So f prime of x is 3x squared plus 6x minus 24. Number two, set f prime equal to 0 and solve. To do that, we are going to factor, which means we are going to factor out number 3 first. So we get 3 times x squared plus 2x minus 8 equals 0. And then we want two numbers, the product is negative 8, the sum is 2, positive 4 and negative 2. So x is either negative 4 or positive 2. Those are the critical points. In this case, f prime of x does not exist, doesn't produce any solution, because f prime itself is a polynomial of degree 2. Formal definitions, maximum or minimum points on a curve. Local or relative extreme values. Extrema is the plural of the Latin extreme. A local minimum is the minimum value within some open interval. Local minimum occurs at the point C in an open interval A to B in the domain if f of c is less than or equal to f of x for all x values in the open interval. A local maximum is the maximum value within some open interval. Local maximum occurs at the point C in an open interval A to B. in the domain if f of c is greater than or equal to f of x for all x values in the open interval. So what are we talking about? Peaks and valleys. Peaks, local max, value, local mean, local. That's all we are saying. Within some open interval. On the other hand, absolute, also known as global extreme values or extrema, are either maximum or minimum points on a curve. That means in the entire domain. So absolute minimum occurs at point C if f of c is less than or equal to f of x for all, and that's the key, all x values in the domain versus open interval in some open interval. Absolute maximum occurs at the point C if f of c is greater than or equal to f of x for all x values in the domain. So as we look at these two cases, first, local mean, local max, local mean. This local mean, there is no other point having a smaller y coordinate. It is also an absolute mean. Local max, local mean, local max. Again, all peaks and valleys are local, first and foremost. This happened to be an absolute because there is no other point has a larger y coordinate. So all peaks and valleys are local extrema. At some point, if possible, one may become an absolute max or mean. Local relative extreme values, Fermat's theorem indicates if a function f has a local maximum value or a local minimum value at an interior point C of its domain, and if f prime exists at C, then f prime must be 0. So as you look at this case, clearly local max, local mean, local max. If we have a local extremum and f prime exists, you see the horizontal tangent line means f prime is 0. This point, f prime does not exist. Why is that? Because it's a sharp corner. And it happened to be, this is a local max. This happened to be an absolute max because no other point has a larger y coordinate. Again, definitely a local max and absolute because no other point has a larger y coordinate. Local extremes in the interior of the function occur where f prime is 0 or f prime is undefined. Maxima and minima of a function always occur at critical points, but critical points are not always maximum or minimum values. So if we have a max, that point has to be a critical point. If we have a mean, that point has to be a critical point. But critical points may not necessarily give us the extrema. We have to further investigate. Let's look at a very simple function everybody is familiar with. And that is y equals x squared. And the domain is all real numbers from negative to positive infinity. This is an open interval. Zero, zero. So absolute minimum is 0 at the pair, 0, 0. It is also a local minimum. Peaks and valleys, remember that. We don't have an absolute max. We don't have a local max. Also, end points can never be a local. It's coming up in a moment, but we need to understand the concept. We are going to look at the same function and we are going to change the domain and restrict it from 0 to 2, which is a closed interval. This is a continuous function with a closed interval. So we have an absolute minimum and we have an absolute maximum, both of them, because the endpoints can be absolute. So absolute minimum is 0 at 0, 0. So this is the y coordinate. whereas absolute maximum is equal to 4 at this pair. We don't have local extrema. We don't have any local max or local mean. Endpoints cannot be local. If anything, they have to be absolute. This is the point. We don't have any other point having a smaller y coordinate. This one, any other point having a larger y coordinate. Now let's make a change and make it half open, half closed, such that this point is no longer included. Therefore, since this is not included, we don't have a minimum. But we still have the maximum. So absolute max is equal to 4 at the same pair, no local max or mean. Let's make it an open interval. That means none of the endpoints are included. There's a hole here, there's a hole here. None of them is included, which means no minimum, no maximum. By that we mean no absolute mean, no absolute max. Of course, there's no local extrema as well. We don't have them either. We looked at those so we can discuss the extreme value or closed interval theorem, everybody. Extreme value or closed interval theorem says if f is continuous over a closed interval of a to b, then f has a maximum and minimum value over that interval. So there are two things that we need to pay attention to. Number one, it has to be continuous. Number two, we're discussing a closed interval, in which case, when we look at this example, max, mean, absolute max, absolute mean. So max and minimum at interior points. In this case, max, mean. Max and mean at the endpoints. They happen, each one at endpoint. And so endpoints can only be absolute. Absolute max, absolute mean. Maximum at interior point, minimum at endpoint. So any of those can happen. So that's the concept of a closed interval theorem. To find absolute max and mean values by extreme value or closed interval theorem, we do the following. Number one, find the critical points, CPs for sure, and evaluate the function at those points, f of CPs. Find the value of the function at the endpoints, evaluate f of A and f of B. The largest value is the absolute max, and the smallest value is the absolute mean. So that's the process we are going to look at, everybody. Find the max and minimum value of f on the given interval. F of x is 1/3 x cubed minus 9x in the interval of -6 to 0. And this is the methodology. But before we discuss the methodology, I want to remind you of something very important. What type of a function we have? What is the domain? And when we say what is the domain, that means where the function is really continuous. Remember that. So a couple of things. Number one, recall. All functions are continuous in their entire domain, regardless of the type of function. When you come up with the domain, that means that's where the function is continuous. Polynomials in general are in the form of a sub n x to the power n plus a sub n minus 1 x to the power n minus 1. Oh, that plus that plus a sub 1x plus a sub 0. This is the leading term. This is the leading coefficient. And these are the exponents. A sub n, the leading coefficient, can't be 0. N which is the degree, is a whole number, and all of those are whole numbers. Whole numbers meaning 0, 1, 2 to infinity. The domain for any polynomial is all real numbers, from negative to positive infinity. So that's just to remind you of what we learned in algebra. Okay. Now, what are we dealing with here? We are dealing with a polynomial of degree 3. Therefore, it has a domain of all real numbers. It's continuous from negative to positive infinity, makes it continuous in the given interval. So extreme value of closed interval theorem, that's why we want to check this. F is a polynomial of degree 3, which is continuous on the interval of negative to positive infinity. It means all real numbers. And therefore, it's continuous in the given interval. So you're checking the given interval, whether the function is continuous or not there. And that's important. So now that we know that, we are going with the methodology. It says find CPs, f prime is 0, doesn't exist. Evaluate the function at the endpoints and the CPs. Absolute max is the largest, absolute mean is the smallest. So let's find f prime of x. 1/3 times 3 becomes 1, x squared minus 9. So x squared minus 9. So we found f prime, and the next step is to set it equal to 0. To set it equal to 0, we're going to factor it into x plus 3, x minus 3. When we set this equal to 0, it results in two answers, -3, +3. The second one, f prime does not exist, doesn't produce any solution. Number one, this is phi, a Greek letter that represents an empty set. And the reason it's an empty set because f prime itself is a polynomial. More specifically, polynomial of degree 2. So f prime does not exist. This is red phi, which represents an empty set. Empty set in set theory. Now, we have two answers only from f prime equal to 0. Is -3 in between the given interval of -6 to 0? Yes. Is number 3 in between? No. So we write only -3 is an element of. So the way we write this, everybody, this means, this looks like an epsilon. This means an element of. That's the meaning of it. Okay. So -3 is an element of the given interval, which means that works, which means we are going to evaluate the original function at the end points -6 and 0, as well as this critical point -3. So we write the original function, f of x equals 1/3 x cubed minus 9x. And we plug in -6 and evaluate it for the first part. We get 1/3 times -6 cubed minus 9 times -6. And -6 cubed is -216 times 1/3 becomes -72. Negative times negative makes it +54. And the answer is -18. So I'm showing you a detailed solution for this. Let's do -3 we put it into the original equation. -3 gives us 1/3. -3 cubed minus 9 times -3. -3 cubed is -27 times 1/3 is -9. -9, -3 makes it plus 27. So it gives us 18. If you plug in 0, clearly you get 0. Therefore, the largest value is 18. So you say absolute max is 18 at this pair. The smallest value is -18. The absolute minimum is -18 at this pair. This is how we write it. Again, as far as your assignments and your exam is concerned, you do the writing the way they ask you. They may just ask you for absolute max or absolute mean or the pair. Just pay attention to the way they ask you and answer it accordingly. We are going to repeat the type of question, that means finding the absolute max and mean. For this function, f of x is x plus 3 to the power of 2/3 minus 5 in the interval of -4 to 5. So we're going to discuss the function and the type of function we have, first and foremost. And so I'm going to rewrite this as cube root of x plus 3 quantity squared minus 5. Just understand, if we were to graph this, we know how to graph cube root of x looking like that, and it has no restrictions and the domain is all real numbers. Then you move it to the left by 3, and then when you square it, the positive portion becomes larger, the negative below the x-axis flips over, and then -5 bring it down. So the domain is all real numbers because it's a cube root. So you write f is a cube root function. Is continuous on the interval of -2 to +infinity, and is continuous over the given interval. Why do we write that? This is what they have given us, everybody. Okay, this is what they have given us, and I hope everybody's okay with that. Okay, so that's the type of function we have. It works. All right, so let's take the derivative of that, f prime of x. And to take the derivative, this one is easier rather than this one. So we're going to write 2/3 x plus 3 to the power of 2/3 minus 1. That means -1/3 times the derivative of the inside, which is 1. And I didn't write that. By now, we are comfortable with this concept. And so this thing has a negative exponent, goes down, and takes a positive exponent. So the answer is f prime of x equals 2/3 times x plus 3 to the power of 1. F prime equals 0, we want to look at, and f prime doesn't exist. When you have a fraction a over b, it's 0 when a is 0. It's undefined or does not exist when b is 0, the denominator. So f prime is 0 if the numerator is 0. But the numerator is a number. can never be 0. There is no solution or just 5. Okay, so one more time. This is a fraction. When you set it equal to 0, it doesn't produce any solutions because the numerator is a number. Large, small, fraction, decimal, positive, negative, makes no difference. There's a number, you can't make it work. F prime doesn't exist or undefined, you set the denominator equal to 0. Now, you don't even have to work it out to see that with x being -3, this expression becomes 0. And is this part of the given interval? The answer is yes. So we write -3 is an element of that works, and therefore we have to evaluate the function at these two endpoints as well as number -3. So let's do that. So we are going to plug in those numbers into the original function in this format or in this format. This is the format which is easier. Starting with -4, so this is the function. If I put -4 here, I get cube root of -4 plus 3 quantity squared minus 5. As you know, -4 and 3 is -1. Cube root of -1 is also -1. Square it becomes +1. So you're looking at +1 minus 5 is -4. -3, I'm not going to even evaluate it. Class, if I put -3 here, let's -3 here gives you 0. I hope you recognize if I put -3, I get square root of 0 minus 5, which is -5. If I put 5 in there, if I put 5, I get 8. So here's how I'm going to write it. This will be cube root of 8 squared minus 5. As you know, cube root of 8 is 2. Square it, you get 4. 4 minus 5 is -1. Those are the answers. And they're all negative. So here's the largest one, here's the smallest one. Absolute max is -1 at this pair. Absolute min is -5 at this pair. So we write absolute max equals -1 at the pair 5, -1. Absolute min is -5 at the pair -3, -5. Again, pretty straightforward, everybody. We're going to move on. Find the absolute max and mean values for the function f of x equals x over x squared plus 2 in the interval of 0 to 4. So first and foremost, let's discuss the type of function. This type of function is a rational function. A function f is a rational function if f of x is in the form of n of x over d of x can't be 0. The denominator as always can't be 0. Where n of x and d of x are both polynomials. That's the restriction. Remember, for rational numbers, the top and the bottom must be integers. For rational functions, the top and the bottom must be polynomials. The domain of f consists of all real numbers except the zeros of the denominator of f of x, namely d of x. In short, you set the denominator equal to 0, you exclude that. That becomes your domain. Normally, there is something to exclude. In this case, class, the denominator, when I set it equal to 0, x squared plus 2 equal to 0, there is no solution. It doesn't produce any solution. This is not 0, this is phi, okay, class? Because this is positive, okay? So worst case scenario, this becomes 0, remember that, because you're squaring any number, the square of any number is positive except 0, which is 0. Whether it's negative or positive, when you square it becomes positive. So there is no solution. Because nothing makes the denominator 0, it's one of those rational functions, which is surprisingly, the domain is all real numbers. So we write f is a rational function, which is continuous from negative infinity to positive infinity. So, or the domain is negative to positive infinity. Therefore, it's continuous in the given interval of 0 to 4. So that's pretty straightforward, everybody. I hope everybody is okay with that. All right. So what happens, let's find f prime of x. And to find that, we are going to use the quotient rule, f prime g minus g prime f over g squared. So numerator gives us 1. The derivative is 1 times x squared plus 2 minus the denominator gives us 2x times the top x, and just put the bottom in x squared plus 2 or the g and square it. So again, pretty straightforward, everybody. We are going to simplify this. We have x squared plus 2 minus 2x squared, this one and this one combine into minus x squared. So a fraction is 0 when the top is 0. So f prime is 0. The top we set it equal to 0. This means 2 equals x squared. X is plus minus square root of 2. F prime doesn't exist if the denominator is 0. Now remember, we showed that x squared plus 2 equals 0 has no solution. If you square it, it has no solution either. So f prime doesn't exist, doesn't produce any solutions. There are two solutions. One of them is positive square root of 2. One of them is minus square root of 2. We have to check. Remember, square root of 2 is about 1.41. Is that in between? Yes. So square root of 2 belongs to that. What about minus square root of 2? No, that doesn't work. Therefore, you are going to evaluate the original function at the end point 0.04 as well as the critical point square root of 2. Let me erase my work so it becomes clear. So we're going to continue in a moment. Let's evaluate the function at the endpoints as well as the critical point square root of 2. So to do so, we are going to use the original function, of course, f of x. And we're going to plug in 0. Of course, 0 gives you 0 over 0 is going to plus 2, 0 over 2. That is 0. So everybody knows this is 0. Let's plug in square root of 2. The numerator is square root of 2. The denominator is square root of 2 squared is 2 plus 2 or square root of 2 over 4. Let's plug in 4. We get 4 over 4 squared is 16 plus 2 is 18 or 2 over 9. So these are the answers. And 2 over 9 is 0.2 bar, everybody. You should recognize this is larger than that. It's about 0.35, but if you don't, you can put it into a calculator and see the decimal representation. This is the largest value, this is the smallest value. The way we write it, absolute max, square root of 2 over 4, which is almost 0.35, an approximation at this pair, square root of 2, comma square root of 2 over 4. And absolute minimum is 0 at this pair, 0, 0. So it's pretty straightforward, everybody. And now we continue with the same type, but the function f of x this time is x to the power of 4 minus 18x squared. We want to find the absolute maximum. First thing first, let's discuss the type of function that we have. Obviously, this is a polynomial of degree 4, continuous everywhere from negative to positive infinity. Therefore, it's continuous in the given interval of negative 4 to 1. So that works. Since it works, let's go with the methodology and find f prime first. X to the power of 4, 4x cubed minus 18x squared minus 36x. Since we want to set this equal to 0, we are going to factor. We factor the 4x out, we get x squared minus 9. X squared minus 9 itself can be factored into x plus 3x minus 3. So we get 4x times x plus 3 times x minus 3. Now, are they equal to 0? Well, set this equal to 0. What do you get? X is 0, x is negative 3, x is positive 3. So we get 3 solutions. 3 solutions, everybody. F prime does not exist, doesn't give us any solutions because f prime is what? Itself is a polynomial of degree 3. And therefore, it is defined everywhere. So f prime doesn't exist, doesn't produce anything. So we have 3 answers. But let's check it with the given interval of minus 4 to 1. Is 0 in between? Yes. Is negative 3 in between? Yes. What about positive 3? No. So we can't use positive 3 because it's not in there. We only use what's within the given interval. Okay, everybody? And so let's evaluate the original function at these two endpoints and these two critical points. We write the original function. F of x is x to the power of 4 minus 18x squared. We are going to replace the x with -4 and evaluate it. We get -4 to the power of 4 minus 18 times -4 squared. This gives you 256. This gives you minus 18 times positive 16 gives you negative 288. And we get negative 32. We are going to use -3, meaning -3 to the power of 4 minus 18 times -3 squared. -3 to the power of 4 is 3 to the power of 4 or 81, because negative or positive to the power of even becomes positive. -3 squared is positive 9 times 18, 172, and we get minus 81. If you plug in 0, clearly you get 0. I mean, there's really not much you have to do. If we plug in 1, we get 1 to the power of 4 minus 18 times 1 to the power of 2, which is clearly 1 minus 18 or minus 17. So those are the evaluations, right? And so we write, all of them are negative except 0, so that's the absolute max at this pair, 0, 0. This is the smallest value, so that's the absolute mean at this pair. We write absolute max is 0 at 0, 0. Absolute mean is minus 81 at minus 3 comma minus 81. So it's pretty straightforward, everybody. All right, let's look at this example. We want to find the absolute max and mean for this function f of t equals t times 4 minus t squared to the power of 1/2 in the given interval of -1 to 2. We need to know the type of function. We need to know the domain. So we are going to rewrite this as f of t equals t times this thing under the radical. So square root of 4 minus t squared. So what are we looking at? We are looking at the product of t, which is a linear function, and square root of 4 minus t squared, which is a square root function. So we write f is a product of a linear function t and a square root function, square root of 4 minus t squared. As you know, a linear function is a type of polynomial, has no restrictions. The domain is all real numbers. The only restriction is created by this. And so we're going to work on that. As you recall, for example, y equals square root of x, x must be greater than or equal to 0, right? Recall, if we have y equals square root of x, x is larger than or equal to 0. In this case, 4 minus t squared must be greater than or equal to 0, which means this is 0, okay? Which means we are going to factor it into 2 minus t times 2 plus t. creates two answers if we set it equal to 0 plus minus 2. And now we go with what is called a sine graph. A sine graph consists of a number line from negative to positive infinity. At the bottom, you use the independent variable x, t, whatever you have. And at the top, you put the function of interest. In this case, is 4 minus t squared. So first and foremost, the name is a sine graph, everybody. So a sine graph is a number line from negative to positive infinity. Over here, you put the independent variable tx, whatever. And over here, you put all the numbers that make the expression either 0 or undefined. That's how the sine graph works. If you don't, nothing makes it undefined, but negative 2 and 2. And you put them in order from smallest to largest. At negative 2, this expression is 0. At positive 2, the same thing. So what do you want to do with the sine graph? You want to figure out the sign here is positive or negative, which one, and how do we find it? We find it using TPs, the test points. So we are going to use TPs, short for test points. I'm reminding you of something we learned in algebra. So in between here, we pick negative 3. You can pick any number to the left of negative 2. In here, the easiest one would be 0. In this case, 3,000, something larger than 2. And then what do? You evaluate this part either in its factored form or in this form with those to figure out what's happening. Obviously, if I put 0 here, I get positive 4, so it becomes positive. If you put it here, the same thing here. So this is positive. Now, the rest of it alternate. How do we know that they alternate? Because if you go back to the factored form, each one has exponent, which is 1, or better yet, odd. If you have now that plug-in, if I put minus 3 here, square it becomes positive 9. 4 minus 9 is negative 5. The same thing for the 3. So you can test it in any event. Then we go back to the restriction. The restriction says we need this to be what? Positive. So we can only see the domain where it says positive here, which is from negative 2 to 2. So we say f is the product of a linear function and a square root function. It's continuous from negative 2 to 2. That's all. Okay. And therefore, it's continuous in the given interval of negative 1 to 2. And of course, the endpoints are included because nothing is in the denominator. So what do? Simple. We start with the methodology and we start with f prime. F prime of t requires the product rule. So let me clean up the work. I don't need to clean up the work. Let's just use this color and say this is f times g. So we need the product rule f prime g plus g prime f. And so t, the derivative is 1 times the second piece, 4 minus t squared to the power 1/2. So that's f prime g. Now we want g prime f. So the second piece we want to differentiate and times t. The second piece, 1/2 times 4 minus t squared to the power of 1/2 minus 1, which makes it negative 1/2, times the derivative of the inside by the chain rule is minus 2t. Let me recap. 1/2 becomes the coefficient. Same thing to the power of 1/2 minus 1 or negative 1/2 times negative 2t by the chain rule. And now that's g prime. What is f? Times t. So we are looking at f prime g plus g prime f. And that's important to see, everybody. F prime g, g prime f. That's extremely important to see. And so we are going to rewrite this as follows. The first piece, this one has no bearing. This one is just the same as this one. Square root of 4 minus t squared. This one to the power of negative 1/2 goes down and becomes the same thing. But what is in the numerator? So pay attention to the numerator. Let me clean up. In the numerator is the product of the following. 1/2 times negative 2t squared. So in the numerator is negative t squared. So what happens? Here's how you write it. Take a look, everybody. This one is the square root of 4 minus t squared. This one is minus t squared because the product of this one and this 2 is minus t squared over this one. What is the common denominator? This one. Therefore, we can write this is the common denominator. And if I want to take a common denominator, I have to multiply these two. And I get 4 minus t squared. And then I have this part minus t squared. And then I end up with 4 minus 2t squared over the square root of 4 minus t squared. All I did, we just got f prime of t. We are going to continue by taking the rest of the steps of the methodology. Looking at f prime being 0, f prime does not exist, evaluation, and so on. So all we did, first, we showed that the domain is negative 2 to 2, therefore this works out. And now we have differentiated. So we're going to continue. That's the function. This is the interval. This is the f prime that we found. So set it equal to 0. A fraction is 0 when the top is 0. 4 minus 2t squared is 0. That means 2t squared is 4. That means t squared is 2, and that means t is plus minus square root of 2. So this is a simple equation we are solving, everybody. F prime equals 0 results in two answers. F prime does not exist. That means the denominator is 0. And that means inside the radical is 0. And we have solved this in the previous page. The answers are plus minus 2. So we have 4 answers. And we have to check with this interval to see what's going on. Square root of 2, we said it's about 1.41. Is it in between? Yes. What about minus square root of 2? That means minus 1.41, no. How about positive 2? That works. That's one of the endpoints. How about negative 2? No, that doesn't work. Therefore, 2 and square root of 2 do work. And we have to evaluate the function at the endpoints as well as these two. We really have to evaluate that one of them because that is common, right? So let's evaluate it at the endpoints, -1 and 2, as well as the critical point square root of 2. And that means we have to go back to the original function and plug in. So here's the original function, f of x. Let's plug in -1 and observe. When we plug in -1, this one becomes +1. 4 minus 1 becomes 3. And the result is minus square root of 3. Let's plug in square root of 2. If I plug in square root of 2, I get square root of 2 times 4 minus. Now t squared, square root of 2 squared is 2. So what we are looking at is square root of 2 times square root of 2, which is 2. Let's plug in 2. We get 2. Square root of 4 minus 2 squared is 4. And I hope you recognize this as 0. So those are the answers. And now we are going to answer this third part as follows. The largest value is 2. So absolute maximum is 2 at this pair, square root of 2 comma 2. The smallest value, the only negative number, is minus square root of 3. So the absolute minimum is minus square root of 3 at this pair. So the writing goes like this. Absolute max equals 2 at square root of 2 comma 2. Absolute mean is minus square root of 3 at -1 comma minus square root of 3. Again, I can't emphasize this enough. When you do your assignments class, you follow what they ask you the way they want you to answer it, okay? They may just ask you for the absolute maximum mean. They may ask you for the pair or both cases.